If you don't understand anything in this video, watch the previous one, link in the description below. Exponents are goofy, but they aren't as goofy as fractions. Exponents can be added, but only if you solve it. There are several laws of exponents which are used to evaluate calculations involving exponents. A very basic one is this. This can be proved very easily. Exponentiation is just repeated multiplication. If we multiply the same number by itself 4 times and then multiply it by itself 2 times, we get a total 6 times. See? Addition. Another one is this. Since exponentiation is repeated multiplication, we use the previous formula to say that we are repeatedly adding the same number, and guess what? It's called multiplication. Another one is this. Now let's see, we can write it in repeated multiplication, find pairs, and boom, there we go. This is another one. Now if we multiply it by this, we add the exponents, and what do we get? The same number, and it's only possible if the number is 1. Now let's talk about inverse. Additive inverse means changing signs, and multiplicative inverse means flipping numerator and denominator. If you remember, division is like multiplication, and when I said 1 over y I meant, if you divide 1 by any number you get its inverse. For fractions, to divide we need to multiply x by the inverse or the reciprocal of y. Dividing 1 by any number gives the reciprocal of the number, because in whole numbers the denominator is 1, because dividing by 1 doesn't change value, and reciprocal means. To invert, and boom, this works for fractions as well because of this. See? It always works. Now dividing a number by itself gives 1, or multiplying with reciprocal gives 1. Any number can be represented like this. Because of this, I mean it should be obvious, but because flat earthers exist, I needed to clarify. Let's represent multiplying 1 with 1's reciprocal, and we add the exponents. The answer is 1, or the exponent is 0, so some algebra would give this. So, yes, this works. Let's talk about reversing exponents, because there are 2 ways to do it and both yield irrational numbers. Irrational numbers cannot be represented as a division between 2 integers. Now first way is logarithm. Raising 2 to what will give 10, now the answer would be log base 210, this is called logarithm. Sounds a bit like algorithm, but what raised to 2 is 10, the answer would be square root or second root of 10. So you see there are 2 ways to undo exponents, one to undo the base and the other to undo the exponent. But unlike multiplication, exponentiation can't represent logarithm, but it can however represent roots. The nth root of x can be represented by this. Now what is the definition of root? If you multiply the nth root of x n times, or if you raise it to the nth power you get x, that should be the definition. So it undoes the exponent. Now using our previous law we can prove this representation. Raising that to the nth power gives x, so if we multiply n by its reciprocal we get 1, or the original number, so yes. And that's roots. Logarithm is pretty complicated. There are 2 things to remember. If there is no base we assume it to be 10, and if your calculator has no base function you can use this formula to get base. What is logarithm? If raise n to log base n m you get m as the answer, so it undoes the base. Few other laws include this and these, and I can prove this. You see x is equal to x to the first power, so we multiply 1 and boom, no change. This law is fairly easy. What number do you raise x to get x raised to y? Well, y, let's see, if you raise anything to 0, you get 1, so yeah, and if you raise anything to 1 you get yourself. This is pretty easy. Negative exponent, multiply that. This is actually hard, but let's put that into exponents. Multiplication and evaluation leads to this. Okay, that's about all of them. I hope I don't have to prove anything. Let's talk about tetration. Tetration, as I said, is just repeated multiplication, and sadly I don't care about the laws. Anyway, I would like to show you 2 cool operators and we'll learn to use them. This is natural log or ln. Basically ln of e raised to x will give x, and e raised to ln of x will give x, and this is product log, or the Lambert W function, or W. I wish I had that in school and life, but anyway. The w of x multiplied by e to the x would give x as the result, and that's it. Anyway, consider this equation. Can you solve it? Probably not. First take ln of both sides, and ln is like log but the base is e, so this goes over here and this can be represented like this. And what's that? If I w both sides I get ln x here. To cancel that x, just do this and there we go. Solved. All credits go to Prime Newtons. I did not know about this bullshit before him. Another question. Okay, a bit weird. Let's subtract this and divide. Now this can be written as this, and let's see. We can add 5 to exponent. By multiplying 2 to 5 or 32. So we get this. Now we can write this as this. All we need to do is make them equal. Just multiply ln 2 to both sides and these two are equal. Use w and we get this. And then divide this, then like subtract and multiply -1 and there we go. Another question someone at my class gave as a joke was this. I solved this one by myself, the rest were solved by Prime Newtons. Anyway, we obviously do this and then ln of both. Then just multiply this. This can be represented like this. And yes, we multiply this. To make these equal, multiply 4. And do the w on both sides to get this. Divide by 4 and raise to e. Let's see what we learned here. Always use natural log of both sides to start out. Try to make a multiplication and an exponentiation equal and try to get everything on one side if all hope is lost on solving an equation. That's all I know on solving tetration. One thing I learnt is that doing higher operation and then lower is additive. And doing the operation same is multiplicative. Using this I'm sure you can create your own laws of tetration. Let's talk about some things. Like how I forgot to give an algorithm for LCM in my other video. Okay, so I will talk about it. To find the LCM of numbers. Lay all of them in a line. Then you find a prime number which divides at least two numbers and then divide those numbers which are divisible. And keep this number here and now keep on using more prime numbers. Some common prime numbers include 2, 3, 5, 7, 11, 13, 17, 19. Use them in ascending order, that will be useful. When you can't go further, just multiply all of these. This is the lowest common multiple. Now PEMDAS and BODMAS can be explained in one sentence: do higher level operations before the lower ones, unless specified. See? Not that bad. I don't get the deal with people in r/confidently incorrect. Let's talk about some fancy operations. Here is the absolute value. This operator turns the sign positive, always. This is a nice way to force the calculator to use positive number always or negative number always. Here is plus minus. An operation being done with this operator yields two results. As you might have guessed, we do plus once and minus the other time. Another one is the sigma operation. So basically you become a sigma every time you use it. What the hell? Oh sorry, I was reading the wrong script. A sigma operator or the summation operator adds for a specific number of times. On the top we write how many times summation occurs. Here we write where to start and here we write an expression and the variable increases and gets added. Here is the factorial, pretty exciting isn't it? It just multiplies the natural numbers equal or less than it. We go into calculus territory when we talk about decimals, so let's ignore them. This is the product notation. This basically multiplies instead of add. We can actually show factorial in here. Pretty cool isn't it? It also follows the same principle or structuration as summation, but here we write a formula and multiplice. I forgot to mention this, but like ln of x is the log of x with base e. I also forgot to tell some kids that e is this. To understand it we are going to learn limits. Sadly, that will be for another video, since I can't upload a video longer than 10 minutes because I don't have 1000 subs, so maybe consider hitting that subscribe. I will have a part 3 for things I missed out.